will go to the next topic, that is the pressure drop. So whenever a fluid is passing through a pipe, then we know that there is always going to be some pressure losses as it is flowing. Now pressure losses can come because of the friction and because of the viscosity. So the equation for pressure loss is HL is equal to 4F will V square by 2GD. That is the standard equation for the pressure loss. Now what is F here? So HL is the pressure head, loss of pressure head or head loss. That is what is the HL. So delta P is the pressure. So we know delta P, we know that P is equal to rho into G into H. So if you want to convert it into pressure, so we get HL is equal to delta P divided by rho into G. So HL is equal to 4FLV square divided by 2GD, where L is the length of the pipe, V is the velocity of the flow, G is the acceleration due to gravity, and D is the diameter of the pipe. F is the friction factor. So it is dependent on the velocity, inner surface and other things. So its equation you can say that if it is laminar flow, if the flow is laminar, then it is equal to 16 by Re. If the flow is turbulent, then it is you are having the equation. So any pipe you are having, if it is laminar flow, the losses will be less. If it is turbulent, you will be having more losses. But if it is laminar, the velocity of flow is very, very less. If you want to have high velocity or large amount of discharge, then you will be definitely having a turbulent flow. When you are having a turbulent flow, definitely the pressure losses will be higher because you will be having V, velocity will be very, very high. So losses also is going to increase. If you are having a fitting, so now fitting means it may be a bend or it may be a coupling or it may be a valve or it may be any other element or it may be a connector from changing from one diameter to another diameter, sudden expansion, sudden contraction you can having. So you are having several issues that can happen, or you can also have obstruction. If you are having a quick acting coupling, you are having obstruction. So you are having different elements which you are incorporating into the pipes, in between the pipes. So all these things also will create certain losses. So standard formula for all these things is loss is equal to K into V square by 2G, where K is the factor for a particular fitting. So for those fitting, how much amount of loss can happen? So it is a constant factor. Then V is the velocity of flow. So if you know the velocity of flow through that particular element, then if you know the value of K, we can determine what is the loss that is happening. Now, in a hydraulic system, you are having different valve elements, you are having different connecting elements, you are having different kinds of couplings. So all these things are there. Now, if you want to determine what is the total loss that can happen, what is the total loss of head that can happen because of the various elements that are present. Now, you should know this one. If you don't know this one, what happens is, your pump has the capacity, for example, you consider that if your pump has a capacity to generate a pressure up to a maximum of 100 bar, then accordingly you are having a motor. You say that you are having a 3 HP motor or you are having a 5 HP motor. Now, your actuator also requires say 100 bar of pressure. So they are two are equal. So we theoretically we say that the pump can drive the actuator to get the required kind of work. Now you have not considered the losses that can happen in the piping arrangement. So you are having lot of valves, you are having large length of pipes, you are having lot of fittings, you are having lot of measuring devices which are going to change the area of flow. So because of all these things, you will be having significant amount of pressure losses. So if the pressure losses is 20 bar pressure, so assume that your pressure losses are 20 bar pressure. Now what happens? Your pump can generate only 100 bar pressure, but at the time it reaches the actuator, 20 bar of pressure is lost, so only 80 bar pressure is going to reach the actuator. So with 80 bar pressure, it is not you are not able to perform the required task. So now you should know what is the actual loss that can happen. Now, generally speaking, we may think that it is very easy to sit and calculate all the different velocities and you have to calculate this thing. So it will become cumbersome. So in order to standardize and simplify the calculation of the losses that can happen, we are having something called as the equivalent length technique. So in this one, what we are doing is, you are having a half-inch valve. So half-inch valve means the connector also will be having a half-inch pipe. Now the loss will be specified in terms of the equivalent length. Means, for example, that half-inch valve will create a pressure loss of say 1 bar. That is, we assume a half-inch valve will create a pressure drop of say 1 bar pressure. Now you are connecting the half-inch valve to a half-inch pipe. Now how much length of pipe is required to create the same amount of pressure drop? So let me say again, a half-inch valve, for example, if it creates a pressure loss of say 1 bar, then how much length of pipe is required to create the same amount of pressure drop? That will be called as the equivalent length of the pipe. So you are having the equation here. For a valve or a fitting, you are having the pressure loss is equal to K into V square by 2G, which will be equal to 4FL E square LE into V square by 2GD. These are the two equations we have studied. So if you are equating it, you are getting the LE is equal to 4 into K into D divided by F. So F is a constant, K is also a constant. So diameter is the fitting. So very easily we can determine what is the value of LE. So once you know the value of LE, then we can add all the equivalent lengths to get the total loss. So for each of these elements, we will be knowing how much of the straight length of pipe is required to create the same amount of loss. So once we know this, it is possible to simply add all these lengths. So we'll say that my regular pipe, whatever is present, it is having 100 meters length is there, and all these walls, whatever the pressure drop they can create, it will be equivalent to say 50 meters of pipe. So whatever pressure drop created by the walls, the same pressure drop will be created in say 50 meters of pipe. Then the total piping length will be equal to 100 plus 50, that will be 150. So this one will be very easy. So now this 150 meters, if you want to calculate the actual pressure drop, you just have to substitute the values. You will be knowing what exactly is the actual pressure drop. So if you are adding more and more elements, you simply have to add the equivalent length of those elements. Then you will know what is the total length of the piping present. So using that, it is possible to determine the total loss very easily. So that is why this technique is more commonly used in the calculation purposes to determine the losses that are happening in the system. So the last one is the valves and the fittings. So what are the different types of valves you are using in the hydraulic system, and what are the different kinds of fittings? So these valves are mainly used to control the flow. We are not controlling the supplying to the actuator. These are mainly used to switch off or shut down the hydraulic system. So sometimes you want to do the maintenance, so you want to close all the valves so that the oil is not continuously leaking. So like that applications, you can use these kinds of valves. This is called as a gate valve because you are having a flat disc-like element. So if you are rotating the hand wheel, the disc is moving upwards and downwards, and you are having the flow here. So this one is called as a globe valve. So here you are having a disc element. You rotate it, the disc will be lifted upwards. You can have the flow in one direction, or you can have the flow in the other direction. Now this one will look very similar to the globe valve, but it is actually a check valve, or it is a one-way flow control valve. So if the flow is coming from the lower end like this, because of the pressure, this valve will be lifted upwards and the flow can happen like that. If the flow is coming in the other direction like this, you are supplying high pressure fluid here, it is acting on the ball and the ball will be pressed downwards, the flow cannot happen. So this will be a one-way flow control valve, or it is also called as a check valve. Now these are some of the fittings. So this is you are using this one to change the direction by 180 degrees. So this is a U fitting. This is a T. So you can have one connection, you can take out two connections. So this is a 45-degree elbow or 45-degree bend. So you are one pipe is coming like this, another pipe is at 45 degrees. So you can use a 45-degree bend. Then you are having a 90-degree bend, or it is a elbow. So 90 degrees you are changing the direction of flow. Now you have to remember that whenever you are making the piping arrangement of hydraulic system or any system, you are not having any angle you want, it is not available. So these fittings are available for standard angles. Now if you want to have some special connections, then it may not be possible by using the tube or pipe. In that case, you have to go for a hose. So if you are having some abnormal angles, say 120 degrees, the two pipes are coming and you want to join them, then you may not be having any fitting. So the two piping elements, you have to make some thread and arrangement so that you can use a flexible coupling at them, and flexible coupling or a hose, you can make them and you can make the connection. So the Transmission line design also is very, very important, and also the design of the various elements, the design of the walls. So all these things are very, very important so that the system is functioning in the required manner to get the required kind of motion or required kind of output. What are the factors that are affecting the head loss? So this is a major important thing we have to remember. So once you are having a proper design, you have to go for the selection of the pump and you have to go for the selection of the motor. That is the important thing. So if you want to have a pump, you have to always know that the pump is designed to deliver the fluid at the required pressure. So whatever pressure the pump is able to create, it should be more than the pressure which the actuator needs. Why it should be more? Because there are going to be losses as the fluid is flowing through the system. So all the losses have to be overcome, and when the fluid reaches the actuator, it should have the required amount of energy. Then only you are able to get the required kind of output. So what are the factors that are affecting the losses? The first one is the flow rate. So as the flow rate increases in a given pipe, say you are having a pipe of diameter say D, then if the flow rate is increasing, then what happens? Flow rate is equal to A into V, that is area of cross section multiplied cross-sectional area multiplied by velocity. So for a given size of the pipe, if you are increasing the flow rate, then velocity is going to increase. So if velocity is going to increase, so what happens to the head loss? So we are having the equation here. Head loss is equal to 4FLV square divided by 2GD. So if velocity is increasing by some value, then the head loss is also increasing. So how much it is increasing? It is increasing by square of the velocity. So if you are increasing the velocity by 2 times, head loss is going to increase by 2 square times. That is 4 times it is going to increase. If you are increasing the velocity 3 times, the head loss is going to increase 9 times. So like that, the velocity is going to affect the head loss. So preferably we want to keep the velocity as low as possible, but if you want to have faster motion, you have to go for the larger size of the pipe. If you are going for the larger size of the pipe, you have to carry more amount of fluid. The cost of the pipe also is going to increase. So you have to make a balance, whether you are preferring the losses or you are preferring the cost. So which one is more preferred? You have to make a decision. Accordingly, you have to select the appropriate size of the pipe. Next one is inside diameter of the pipe. Again, it is related to the discharge only. So inside diameter is small, means for a given flow rate, the velocity is going to increase. So that is how the inside diameter is going to affect the head loss. So if the diameter is small, what happens to the head loss? Head loss is going to increase because again, if you are seeing the equation, so head loss and diameter are inversely proportional. If the diameter increases, head loss is going to decrease. If the diameter is reducing, the head loss is going to increase. The next one is the roughness of the pipe wall. If the inside surface of the pipe is very rough, then definitely there will be going to be more friction or there will be more turbulence in the flow. If there is more turbulence, then the losses also are going to increase. Next one is corrosion and scale deposits. So if you are having corrosion, means whatever the smooth pipe is there, that is going to be becoming rough, and you are having some unwanted material which is deposited on the surface of the pipe. Then you are having scale deposit. So scaling means some salt or some other material which is formed on the surface of the inner surface of the pipe. So all these things are going to increase the turbulence or creating resistance to the flow. So because of all these things, again the head loss or pressure losses are going to increase. Next one is viscosity. Viscosity by itself is resistance to the flow. If the viscosity increases, the pressure loss also increases. So viscosity is again related to the temperature. So at low temperature, the viscosity is higher, so losses will be higher. At high temperature, viscosity will be less, losses will be less. But we have to remember, when the temperature increases, there is a chance of oxidation, there is a chance of catching fire. So we have to decide what should be the appropriate viscosity for the particular fluid, and within that viscosity range, you have to maintain the temperature. Or if you need a heater, you have to use a heater. If you want a cooler, you have to use a cooler to make sure that the fluid is operating in a safe range at the required viscosity level. The next element is the length of the pipe. So if you are having a very long pipe, then definitely the losses are going to increase. if you are having a very short length of the pipe, the losses are going to be reduced. So you should not create very long flow paths from the pump to the actuator. You have to always make sure that the length should be as small as possible, but to the required level. So you should not make it very small and very tight. So in order to reduce the losses, you should not make them very tight. Then the flexible coupling, flexible piping may simply break. Then it creates more problems. Next one is fittings. So whatever fittings you are using, you have to always make sure that there is a gradual change in direction of flow. You should not make abrupt change in the direction of flow. And whenever you are changing the direction of flow, you have to use some good radius. So whatever the bend or elbow you are using, you should have a generous radius so that the direction of flow is gradually changed and the losses are going to be minimized. So if you are having very sharp change in directions and other things, or if you are having too many fittings, then also the losses are going to increase. Next one is the straightness of the pipe. So if the pipe is having some change in direction, or if it is going by some angle, then you have to make sure that you are giving a good radius. Otherwise, if you are simply making it sharp turns, then there will be losses which will be increased. So if you are having sudden change in directions, the losses are going to increase, and also it may create some back pressure, or it may simply damage the piping if you are changing the direction very abruptly. So these are some of the factors which are going to affect the head loss, and these are also some of the factors which you have to consider in the designing of the hydraulic transmission lines. That is also another important